Hi there, welcome to PIC Computing, A-Level Computing video number 80, and we're talking about programming, and we're looking in particular at these things called variables and constants. The first part of this video might be useful for people who are new to programming. We'll look at variables and constants, we'll see what they are and why they are so important to programming. So if you're new to programming, you might just want to watch the first part of the video. If you're a little bit more involved in programming, then we'll start to talk a bit later on about how variables and constants can be defined properly to write quality, maintainable code. We'll also look at something called scope and local and global variables, and also something called initializing. But those last three bullet points are a little bit more advanced. If you're new to programming, the first bullet point will be the most important part. So firstly, variables. Variables are a memory location that is used to store data. So it's just a place on the random access memory that is reserved for us to use to store data in our program. Variables are identified by a name given to them by the programmer. The value of the data stored in the variable can change whilst the program is running. It might have one value on one line of code and then be given another value on another line of code, and so on and so forth. Therefore, the purpose of a variable is to allow the programmer to change the value of a piece of data whilst code is running. This is really useful, as at the start of programs they will not know what the final value of the data will need to be. Hence the name variable, because they store data that varies from the start of the program to the end. Constants, which we might also know as literals, are very similar to a variable in that the constant is a space reserved in memory to store data, but then it's different to a variable in that a constant has a fixed value. The value is set at the start of the program, and the value does not change at all during the duration of the program running. It doesn't vary. Constants can make code easier to read. It's easier to remember than a value for a programmer whilst he or she is writing code. So an example, instead of remembering the value of pi used in a program, we could just call it pi, and that's easier for somebody to remember, and it's easier for somebody to type in to some programming code. Let's have a look at an example now of a program that uses both variables and constants. What this VB.NET program is going to do is accept input from a user on a rate of pay and a number of hours worked, and then calculate their pay. So if we look at the code behind the button, at the top here I've got 4 variables declared and then a constant declared. Now when we declare variables, we use the dim command in VB.NET, and we give the variable name or identifier, and we have to specify a data type. And I've used a double data type for rate, because double is really good for storing decimal places. So if somebody's rate is £1.50 an hour, big hitter, then they'll have to be able to store 0.5 or 0.50. So double's a good data type for that. Hours is declared as an integer because they will work whole hours and not part hours. So integer, whole numbers is good for that. Pay is going to be double, and then I'm going to have a message displayed on screen at the end of this subroutine, this procedure, which is going to display the pay. I've also got my constant, which is overtime rate, which never changes, is a double again, but always stays at what we call time and a half, 1.5. What we'll do in a moment, well, I'll just put the breakpoint on ready, is step through the code, and what we'll see is our variables being used and sometimes being reused as we step through it. We'll see our constant being used, but just before we do, it's just worth mentioning about the prefixes to variable names. You'll see those there, DBL, I, DBL, and S. You might spot a little pattern there, but we'll talk more about those in the video later on. So let's run this and see this working. So if I put in my rate of pay, which might be £1.75, yeah, I earn a lot of money, and my hours for the week might be 35. If I calculate my pay, here on this first line, the variable is receiving a value. Just note, though, that before it receives the value from the user, it's actually set to 0.0. A little bit more about that later on. So when I move on to the next line, it's received the value of £1.75, my pay rate, and hours is going to receive 35. It's currently 0, but when I step onto the next line, it's then 35. So if, and we're using our variable again here, I hours is less than or equal to 35, and it is, then the pay variable is set to the rate variable times by the hours variable. So pay is set to £61.25. So if I then move down the code, I'm starting to set another variable, this time a string variable, which is currently set to nothing. But when I move on to the next line, it will now be your pay is, and a new line. And then it's reused. Again, here this is a variable being reused. We're setting a variable to be itself and something else on the end, which is the pay formatted nicely into pounds and pence. So there we can see what it's going to show on screen in a second, and it does. Okay. If my hours worked was going to be higher, so I've done some overtime, then again it's doing the same things here. It's setting the variables. The variables, by the way, are all reset at the start of the code, start of the subroutine being running, so they're all set to 0, so they receive new values from the user. Hours aren't less than 35, so it's going to set my normal pay on this line, but then the hours variable is reused to basically then contain the number of overtime hours, which is 5, and then we're setting pay again. We're reusing pay to add on the overtime, which uses our constant as part of the calculation. So then I'm going to come out with hopefully a higher amount of money. Oh yeah, I can go out tonight. Now I've been paid that. So there's some variables and constants being used in a VB.NET program. We're now going to look at something called identifiers. Variables and constants, as we've seen, have names. And these names are also referred to as identifiers. When choosing identifiers for variables or constants, we've got to consider this. Most programming languages require identifiers to start with a letter, and we should use meaningful names. So you saw I used DBL overtime rates and not just called it any old name. Spaces are not allowed. Try to use underscores or sentence case to make identifiers easier to read. So this example should hopefully show you why. Using capital letters at the beginning of words within the identifier, or underscores between words within the identifier, instead of just writing it all in small case, do make the variables easier to read. Some other important tips include try to use prefixes. As you can see, my overtime rate variable has the prefix DBL, as it is the double data type, and DBL is double shortened. My message variable had the prefix S, as it is the string data type, and this helps other programmers in your team know which data type is used without having to look where the variables are declared at the top of the code. So as they're reading code and they see a variable being used, they can tell what sort of data type that should be. Those are two examples of prefixes that I used when I worked in industry, and different companies will use different prefixes, and these are part of a company's coding conventions, which we'll look at further in a future video. Another thing about identifiers, we can't use reserved words in programming languages, and there are lots of them, such as if, while, repeat, etc. Because of course those are used elsewhere in the programming language. Now we're going to look at this thing called scope. When we're talking about scope, we refer to two types of variable, and the first is local variables. Local variables are declared and used inside a subroutine, so a procedure or a function, and can only be used or changed within that procedure or function. They're declared or created when the procedure or function is called and destroyed when the procedure or function ends. So their scope lies only within a subroutine. Global variables are declared at the start of the main program. They can be used or changed within any procedure or function called by the main program. Their scope then lies within a whole program and not just restricted to individual subroutines. If we look at the code from my example, then say I wanted to use the DBL pay variable not just in this subroutine but in any subroutine from the program, then I might remove the declaration from the subroutine and move it just into the main program. It would then be able to be used by any subroutine. And just as a side issue, in the coding conventions that I know, I might put a G or possibly even an M where there's a slight contradiction, but that just tells me that that variable is global. So it's a good way of including some useful information for the programmer in the global variable identifier. Some tips on whether to use local variables or global variables. Try to use local variables as much as you can. They're less memory intensive than global variables, so if you use more local variables, it means your program will run quicker. Using local variable also avoids different subroutines messing up the value in that variable. Only use global variables if the variable needs to be accessed by various subroutines within your program. There is a big contradiction between what the textbooks at A-level will tell you and what VB.NET requires in terms of global, local, and something called modular variables. So VB.NET and other programming languages may refer to global variables as modular variables, so it does start to get confusing. Global variables in VB.NET are variables that can be accessed or changed by any module of code, whether that be a form, a module, or a class module. It's not too important to get your head around this now. What is important that you remember the definitions on previous slides for the exam when it comes to variables, constants, identifiers, and particularly local and global variables. Remember the definitions we have talked about previous to this slide. I just wanted to make you aware of this contradiction. Thinking about initializing variables and constants. Some programming languages initialize variables automatically when they are declared. This means they are automatically given a default value. We actually saw that when I stepped through the program earlier. Say my iHours, the integer variable, was set to 0 before it was set to anything else. So it was given a default value. So VB.NET does this for integers, setting them to 0, for Boolean, setting them to false, for string, setting them to an empty quote. It did it for the double data type as well, didn't it? It set it to 0.00. So VB.NET will initialize variables for you. If variables aren't initialized automatically for particular programming languages, or if they aren't given a value manually by the programmer, then programs will not work. And I think JavaScript's an example of a programming language or a scripting language where variables aren't initialized. Constants must be given a value manually by the programmer in VB.NET. So they aren't initialized. They have to be manually given their value. Hope all that was helpful. Bye for now.